Good morning, everybody. Primary sedimentary structures, those formed by erosional process. Um, Although these structures are mainly formed by erosion, but sometimes along with the erosion, there was some deposition also occurs. Now, as the name suggests, that erosional sedimentary structures, so we are very much aware that these are formed by erosion. Now, this erosion is happened due to differential process or differential force acting on the bottom sediment surface, and this erosion is formed either by the abrasive action of any kinds of tool such as the any sharp pebble or cobble grain, or any kind of bone fragment or shell or wood fragment. These are used as tools to scratching or scraping the soft sediment surface by the current. And secondly, some swirling current itself, that is the eddies, they during their movement, during their swirling action, they can uh, erode the soft sedimented surface differentially. So due to this fluid stress, that is the eddy current, and scratching by some kind of moving tools differentially on the sedimentary surface, uh, the erosional sedimentary structures are formed. Now, these erosional sedimentary structures can be of two types, as I already told you. They can be formed by the eddy currents or the moving uh, turbulent waters, that is known as scour marks, or they may be formed by some kind of moving tools, those are known as tool marks. So uh, two kinds of erosional structure is the scour marks, another is the stool marks. Now these structures are mainly found in the rock record as the negative imprint on the above lying bed, so that is preserved on the bottom surface of the above unit, and that is why they are known as sole marks. Sole means bottom. So if we just elaborate the term sole mark, that is known as bottom surface sedimentary structures. Now why they are called sole marks? Firstly, you have to know that any kinds of sedimentary structure, mainly the erosional structure, they are best preserved in the or best formed in the fine grained sedimentary rocks, that is the clay rich sedimentary rocks. Now erosion can happen in any kinds of sediments. That may happen in clay rich sediment, that may happen in sand rich sediment, or any size grade sediments. But after erosion, those erosional depressions or those erosional scours, they may be distorted or they may be reshaped by the moving current, until or unless the sediment itself have some cohesive property so that they can resist the erosional form or erosional feature from other superficial activities. That is why they are formed in any kinds of sedimentary rocks, but after formation their shape size can be retained well due to the cohesiveness nature of the sedimentary grains of the clay particles or mud size particles. They are best retained on the clay-rich or mud-rich sedimentary rocks. Now, in this diagram, you can see that some kinds of erosion happen in this black clay-rich sedimentary layer, and due to this erosion, a depression formed in this black clay-rich sediment. Now, after formation, when the erosional power of the moving current ends, then deposition happen from the overlying fluid. So these sediments are deposited in this scoured portion and they are filled up. So this covered portion along with the overlying sedimentary unit, this is made up of another type material compared to this black clay rich sedimentary unit. So you can see a distinct difference between these two units. This white is might be it is coarse grained sedimentary unit, and this black one is fine grained sedimentary unit, humus rich. So because when a rock is humus rich, it becomes very dark in nature. So the erosion which is basically formed in the clay rich sedimentary rock, that is later filled up by the overlying material in a later time when deposition resumes. Now it may happen or may not happen due to some tectonic forces. These sedimentary horizons or these sedimentary units are rather distorted from their original uh, tilting or from their original position. Now after that, when these rocks are exposed in the superficial condition, so after deposition of these sediments, they go through burial and lithification, and they may or may not go into any kinds of diastrophic phenomena. And after that, when they are exposed in the superficial process, so superficial process like the action of wind, water, glacier acting on these rocks. Now, interestingly, here you can see the alternate coarse grain and fine grain layers, but you can see that the fine grained layers are readily eroded or more eroded than the relatively coarse grained layers. It happens because these fine grained layers are often broken in pieces as clast. As you know that clay rich sediments, there are many weak planes and mostly they are dominated by phyllosilicate group of minerals, that is the muscovite group of minerals. So the during the superficial process acting on these rocks, these clay rich sedimentary layers, they are easily eroded as clasts, as not a single grain, but they are eroded as chunks. So in this process, these clay rich sediments are easily fragmented and eroded by the superficial process. So what remained, that this erosional portion which happened in the clay rich sedimentary rock, that is during time of superficial exposure, that portion is eroded, but what remain is the negative imprint of that erosional feature in the overlying coarse grained sedimentary rock. So although this original erosional feature which formed in the clay rich sedimentary rock is removed away during erosion, but the negative imprint of that feature is preserved or is found in the overlying sedimentary rock. This sedimentary rock is relatively coarse grained. So that is why you can see that the original erosion feature now is preserved as the bottom surface sedimentary feature on the above lying sedimentary unit. So basically this feature is not formed during the deposition of this sedimentary unit. This coarse grain sedimentary unit, during deposition of this coarse grain sedimentary unit, this feature is not formed, but it acts as a replica of the bottom layers feature. So that is why it is preserved at the bottom surface sedimentary structure, and it is known as soil mass. Now there are various kinds of erosional features or erosional sedimentary structures formed. Uh, Mostly they are formed or they are preserved as bottom surface sedimentary features, but there is some sedimentary features which can be found or which can be preserved in the superficial condition, that is on the top surface. So this is top surface sedimentary features. One of these top surface feature is known as current crescent. Now one interesting thing is that when I discuss about the different kinds of erosional sedimentary structures, I told you that there are two types of erosional sedimentary structures. One is the scour mark, which is formed due to the moving eddies, and one is the tool mark, in which some kinds of tools are uh, present for formation of those erosional structures. Now, that tool is maybe a rock fragment, maybe a wood fragment, maybe a shell, it may be anything. Now, that tool may be static, that is not moving from its original place, or that tool is moving with the current. So, two conditions are there. In the first case, the tool is stationary. In the second case, the tool is moving with the current. So when the tool is stationary, that is not moving along with the current, then that tool act as a obstacle to the moving current. Due to this obstacle, the current in the upstream side of that tool, they readily eroded. So the obstacles lying in the way of the current, they resist the current to flow, thereby the current moved past this flow, and during moving passing this obstacle, they eroded mostly in the up current side and the sidewise portion of the obstacle. Simultaneously, in the down current side, here lies a shadow zone in which erosion does not occur. You can clearly see that the elevation difference between the other parts of the sediment surface and these upstream and sidewise portion of the obstacle and the downstream portion of the obstacle. So you can see a depression in the upstream and sidewise portion of the obstacle. That means erosion occurs in this position, whereas little elevation in the downstream side of the obstacle. That means slight deposition occurs is occurring in this portion. So this portion is basically deposition occurs because here lies a shadow zone. That means erosion is not occurring at that portion. So generally a semicircular or something elliptical depression found along the upcurrent side of the obstacle, and a tail of deposition found in the downstream side. These kind of features are known as current crescent. Now, these current crescents are very good indicator of directing or informing us about the flow direction. The tail of the deposition, that is the tapering end, you can see that deposition is maximum in width in this portion, and as we move in the down current, the deposition is gradually tapering and it gradually mixed with the erosional surface and the other sedimentary surfaces. So this forms almost a triangular shaped depositional pattern in the bottom current end, and this angular side, that is the tapering end, indicates the down current portion, that is flow moving from bottom to right. That means from the erosional side to this depositional tapering end. For in this picture, it is from bottom to top. In the right hand picture, you can see the erosion occurs here in this portion, and the tapering end is here in this portion. So my flow is from top to bottom. So always remember that this depositional tapering end indicates the down current, and if you try to observe the erosional portion, the closure of this erosional portion indicating the upstream current, because this circular to semicircular erosional depression happened in the upstream portion that closes in the upcurrent portion and opens in the downcurrent portion. Okay, so this feature is known as current crescent, and they are very good indicative of your paleo flow, that means ancient flow direction, and they are easily preserved in the rock record. Second structure, uh, these are formed by erosional as well as depositional also. This is known as pebble imbrication. Basically, imbrication refers some kinds of depositional pattern of clast, that is the clast is preferentially oriented uh, in the depositional bed, and that preferentially oriented uh, clast are known as, or that feature is known as imbrication, or the structure is known as imbricate structure. The clast or pebble is known as imbricate clast or imbricate pebble. Now, what happened or how this orientation is formed? This imbricate structure is best found in the higher energy condition of a moving water, that is in the higher flow regime, mainly in the hilly terrain, where these large size clasts are carried by the moving current, that is the river. Now these clasts are deposited haphazardly in the bottom surface of the moving water. So some clasts deposited horizontally over the sediment surface, and you can see some clasts deposited in an inclined way. This inclination is towards the down current. Here in the next year, you can also see that one clast is deposited in a horizontal fashion and one clast is deposited in an inclined way, and the inclination is towards the uh, down current direction. Now, what happened after that? Due to deposition of this inclined orientation of this clast, these clasts now act as a barrier or obstacle to the moving current. You can see that this moving current is restricted by the orientation of this clast. So water basically gathered in this bottom portion. Similarly, this moving current is restricted by this clast. Water basically gathered in the bottom portion. So what happened, as the energy condition is high, this clast after deposition, that is basically toppled. In the bottom picture you can see that the clast previously oriented like that, now later current, when it founds this clast as an obstacle, they basically toppled it like that. So now the inclination of the clast is towards the up current direction. Similarly, in this clast also, it was previously oriented like that, and after toppling it was oriented or tilted towards the up current direction. So day by day or time by time, the clast are deposited in this fashion. So first class is deposited like this, then some another class came and they try to follow that orientation. So successively the class, all the class are oriented or tilted and deposited with tilting towards the up current side. This orientation nature or tilting nature of class is mainly found by the discoidal shaped or uh, some tabular clast. And actually tabular term is not the shape term for sedimentology, so you can use the term bladed clast. So the flat discoid clast, they are most preferentially oriented by this process. Now here you can see that orientation of this clast is occurred after their deposition. They are reoriented by the moving current. Now it may happen in another way by erosion also. Suppose a clast deposited here, this clast deposited here first. Now it acts as an obstacle like I previously told in the current crescent portion. This clast acts as an obstacle. So erosion happened in the upcurrent portion. Now due to erosion in the upcurrent portion of this clast, there will form a depression. So gradually with increasing the depression, this clast is fall within that depression, and due to that this clast is now tilted towards the upcurrent direction. So suppose this is my subsedimentary surface, here lies a clast. Now due to obstacle here erosion occurs, so a depression or void is happening here. With time, gradually this clast is, due to the action of gravity, tilted down to this erosional halo, erosional void, and ultimately it will show a preferred orientation tilting towards the upstream current. So this tilting nature of discoid shaped clast may be simply formed by deposition and after reorientation, or it may happen by deposition then erosion in the upcurrent bottom sedimentary surface, then reorientation of the clast in the upstream tilted position. So anyway, these clasts are mainly found in the higher flow regime of a river, and they show preferred orientation or preferred tilting towards the upcurrent direction. So by that way, these clasts are very good indicator of indicating the flow direction, because the tilting nature, if the tilting nature is indicating the upcurrent direction, so the opposite direction is definitely my flow direction. Okay. So in the right hand picture you can see that the clast slightly discoid shaped, slightly flat pebbled, they show a preferred orientation towards this direction. You can see this class also oriented here, this is also oriented in this, and these are also. So all these class, you can see they are tilted towards the right hand side. So this means that the right hand side is the upcurrent direction. So definitely the left hand side of this picture indicating the flow direction. This is the significance of imbricate structure, and this imbricate structure uh, by this way helps us to determine the flow direction. The next erosional sedimentary structure is known as fruit crust or fruit marks. These fruit marks are also sole features, that means they are preserved in the overlying sedimentary unit. Basically fruit marks are discontinuous elongated depressions formed by the erosion of the bottom clay rich sedimentary rocks, and this erosion is mainly formed by the swirling action of water. The eddy currents, due to their swirling action, due to their rotational movement, they differentially erode the bottom clay rich sediments and form some erosional depressions, which are later filled by the overlying sediments and preserved as the sole features or negative imprint of the original depositional features. So as it is the differential erosion occur due to the swirling action of the moving current, so mostly these fruit marks are discontinuous, they are something elongated in shape, and you can see that if you look the inclination of the two sides, one side is steeply inclined, this side is steeply inclined, and this side is gently inclined. You can see in this picture also, this side is steeply inclined and this side is gently inclined. So there is a difference in inclination within the clast. One side is steeply inclined and one side is gently inclined. The steeply inclined side is the upstream side and the gently inclined side is the downstream side, and this gently inclined side is gradually uh, tapering down to the sedimentary surface. So swirling action happens there, they erode there, and now current drag them towards the downstream side. So they uh, meet with the sediment surface. So that is why a steeply dipping upcurrent side formed and a gently dipping downcurrent side formed. So my current moving direction or flow direction is from the steeply moving side towards the gently moving side. Okay. Now these are generally elongated, 2 to 10 centimeter long, uh, scoop shaped depression, and they may vary in shape and size, and depending on their variation of shape and sizes they can be they are classified into different types. Some are linguiform, like the linguate ripples from that term linguiform. Some are triangular, some are elongate, more or less symmetrical, and some are bulbous. But Again, keep in mind these fluids are very good indicator of flow direction. Flow is from the steeply dipping side to gently dipping side, and these are preserved as bottom surface sedimentary features, that is negative imprint. Now another same kind of feature is known as scour and fill structures. These scours are also formed in the same way like the fluid forms, that is they are formed by some moving eddies. But the difference is that in the fluid mass, the overlying material is filling the erosional depressions, whereas in the scour and fill structures, they are basically filled by some coarse grained material, and these coarse grained materials, they show some kinds of inclined laminae also. The laminae are oriented like this fashion. So very fine crude laminae are found in this matter, and you can see that there is a distinct difference in the sediment size in contrast to the surrounding host sedimentary rock. You can see the host sedimentary rock is much finer in grain size compared to this filled up eroding or scoured portion. This scoured portion is filled up with coarse material. But in terms of flute marks, this eroded portion is filled up by the overlying material. But in terms of scour marks, scour is basically erosion. The erosion is formed due to eddy currents, and when the erosional eddy current passed away, depositional resumes. Basically these are lags, channel lags. So these are the bed load sediments which is moving along the bed load. Now during movement they found these depressions, they deposited, and now the moving current is not able to move them to further down current direction. So these kinds of coarse field scour marks are formed. So this is known as scour and fill structures. You can differentiate a scour and fill structures from the flute cast by their difference in grain size mainly, and the inclined laminae found within the scour and fill structures. Next is the groove marks. Uh, these are elongated or nearly straight ridges, again formed in the fine-grained sedimentary rocks. Uh, Basically, uh, these are formed by some moving tools over the soft sediment. Now, this is relatively continuous with respect to the other erosional sedimentary structures previously I told you. These groove marks are the troughs formed due to erosion in the soft sedimentary rock. Commonly, they are few millimeters to few centimeters in width, and the length might be few centimeters to meters, few meters. These groups are basically produced by some tools. Now, the main difference of these groove marks from the previous ones, that in the previous erosional features such as the scour and fill structures, the flute marks, they are formed by the moving eddy currents. So basically those are the scour marks. Now these groove marks here the moving current is not only responsible, but a tool, that may be a pebble, that may be a shell, they scratch the soft sediment surface. And due to this scratching or scraping of soft sediments, these continuous linear ridges, or basically continuous linear groups in the bottom sediments, soft sediments, they are formed by erosion. Now, again, after erosion, these are filled up by the overlying sedimentary material and preserved as negative imprint as some elevated ridges in the overlying sedimentary rock. So again, these are bottom surface sedimentary features. These are mainly formed in the clay rich sedimentary rock. But a difference from the previous feature is that here, a, rather than moving eddy current, a tool is involved here. And from observing the groove marks, you can only sense the paleocurrent direction. That is, if you see this ridge, you can say that my flow is either from this direction to this direction, or by this direction to this direction. So you can sense the flow, but you cannot precisely say the exact flow direction simply by observing the groove marks. So along with groove marks, some other kinds of evidences are required. So the grooves are indicating you that is flow is either from this direction to this direction, or from this direction to this direction. Now, in groove marks, there is a special kind of groove marks which is known as chevron marks, in which the tool directly, instead of directly scraping the sediment surface, the tool moved parallel to the surface and very close to the sediment surface, just above the sediment surface. Now, due to the shearing effect during, during this movement, the sediment film on the top surface of the uh, soft sediment over which the tool is moving, they show some chevron shaped, that is in this angular shaped marks, groove marks. And now these angular shapes are indicating, or this angular uh, closure, this angular shape, they indicate, that is the closure of this V indicating my bottom current direction, that is the flow direction. So chevron marks are a special kind of groove marks in which the sediment surface is not came into direct contact with the moving tool, but the moving tool moves very close to the sediment surface and thereby forms some V-shaped depression, the closure of this V indicating the uh, downstream direction or flow direction. Next is the gutter cast. So this gutter cast is basically a larger version of groove marks. In groove marks, I told you that the diameter or width is only few millimeters to few centimeters. In gutter cast, they are tens of centimeters wide. In groove marks, the length of the grooves is few centimeters to few meters, and gutter casts or gutter marks are mostly few meters wide. So they are basically formed by the same way like the groove marks, that is by some kinds of moving tools scratching on the soft sediment surface, uh, and their dimension, their size, shape is larger compared to the groove marks. The other things remain same. They are also forming some U or V shaped depressions. They are also saying the sense of flow, that is flow either moving from this direction to this direction, or flow is moving from this direction to this direction. So basically the flow, these gutter marks are parallel to the flow direction, not indicating the precise direction of flow. Some other kinds of tool marks are also found in nature. Among them, the first one is the prod mark, which is mainly formed by the saltation movement of sedimentary grains. These prod marks are also asymmetrical, elongated, semi-conical to triangular. You can see that the this side, this side, and this side are not same in size and shape and inclination, so that is why they are called as asymmetrical. The upstream side is gentle and downstream side is steeper. So from this feature you can see that the tool moves from the downstream side, from the gently sloping side towards the upstream sloping side. These marks are formed when a tool uh, moves by saltation movement, that is alternatively came in contact with the bottom sediment, and they impact on the soft sediments with a high angle and form these kinds of asymmetrical depressions. Now in contrast to the prod mark, in case of bounce mark, the depression forms by the same kinds of saltation movement, but here the tool approaches or tool impacts the soft bottom sediments at low angle compared to prod marks. So the inclination angle difference is there. In case of prod marks, the inclination angle is high. In case of bounce mark, the angle of impact of the tool to the bottom sedimentary surface is low. The next is the brush mark. Again, it is formed by the saltation type of movement. In brush marks, the angle of incidence of the tool is much lower compared to the bounce mark. So if we compare from prod mark to bounce mark to brush mark, these are formed by saltation type of movement, and gradually the impact angle decreasing from prod mark to bounce mark to brush mark. And in all the three cases, they are formed some asymmetrical depressions. Uh, the depth of the depression varies depending on the inclination angle of the tool, and by this way three types of marks are formed, and again these are preserved as negative features on the overlying sedimentary rocks. The next two types of bottom surface sedimentary features which we preserved in the sedimentary rocks is formed due to the bed load movement on the soft fine grained sedimentary rock. The first one is roll marks, when a sedimentary grain rolled over uh, the soft sedimentary rock, that is all the sides, all the surfaces of the sedimentary grain alternately came in contact with the bottom sediment surface. So depending on the angularity of the sedimentary grain in different sides, various size and shaped depressions or erosional scours are found on the bottom sedimentary surface. But here, as the grain is always in contact with the bottom sedimentary surface, so the individual shape and sizes of the depressions may vary, but these depressions are continuous in nature, because these kinds of erosion formed by the moving tool during their bed load movement when the tool is always in contact with the bottom sedimentary surface. Uh, the last one, which is known as skip marks, here the tool makes impact on the sedimentary surface at a regular interval. That is, this is also kinds of saltation movement. The markings arranged in a row and uh, formed, produced essentially by tools moving in saltation, um, but the hitting sediment surface is very regular compared to prod mark, bounce mark, or brush mark. So here, in case of prod mark, bounce mark, and brush mark, they are very occasional hitting of the tool to the bottom sedimentary surface. But in case of skip marks, which is also one kind of uh, saltation movement, but it is more regular than these three. So basically, you can say that skip marks is a in between the bed load movement, that is the roll marks, and these three. So it is almost moving as bed load, but uh, after certain interval of very short distance, it came into contact with the sediment, so thereby forming a some marks on the bottom sedimentary surface, and those are known as skip marks. So that's all about the uh, erosional sedimentary structures. The importance of erosional sedimentary structures is that as they are mostly preserved as the overlying sedimentary unit, that is the negative imprint of the original feature preserved in the overlying sedimentary bed. So by studying them, you can easily uh, identify the stratigraphic top and bottom direction. Secondly, some kinds of erosional sedimentary features like the flute marks, the prod marks, due to their asymmetrical nature, they give you the precise flow direction. Whereas the other erosional sedimentary structures like the gutter marks, the groove marks, the skip marks, the roll marks, they are oriented parallel to the flow direction. They are not giving you the precise flow direction or the exact flow direction, but by observing them, you can say that they are oriented parallel to the flow direction. So that's all. That's a brief introduction about the erosional sedimentary structures. Thank you.